Okay, so we are back again. As we have studied a little bit of energy, right, watt hour. So, one different example, then again we will go to the circuit theory just to give you some some ideas regarding energy, right. For example, like this is example 1.12, that is example 12. That a residential consumer consumes 800 kilowatt hour in the month of March, right. Determine the electricity for the month using the following rate schedule, right. For example, base monthly charge is rupees 12, first 100 kilowatt hour per month at rupees 1.5 per kilowatt hour, say next 200 kilowatt hour per month at rupees 2 per kilowatt hour, and over 200 kilowatt hour per month at rupees 2.5 kilowatt hour, right. Now we have to calculate the electricity bill. So, base monthly charge is rupees 12. Now, 100 kilowatt hour at rupees 1.5 per kilowatt hour. Therefore, 100 kilowatt hour at rupees 1.5. So, 100 into 1.5. So, it is rupees 150. Then next 200 kilowatt hour per month rupees 2 per kilowatt hour. So, it is your next 200 kilowatt hour at rupees 2. So, it is 2 into 200. So, rupees 400. Now, total is your 800 kilowatt hour. Now, here it is 100 plus 200, 300 kilowatt hour already we have computed, rupees 150 and 400, remaining will be 500 kilowatt hour, because 800 minus 100 minus 200. So, remaining 500. So, 500 kilowatt, remaining 500 kilowatt hour will be at rupees 2.5. So, it is given 2.5 per kilowatt hour. So, rupees 2.5 per kilowatt hour. So, 500 into 2.5. So, rupees 1250, but monthly base charge is rupees 12. So, plus 150 plus 400 plus rupees 1250. If you add up all, total charge will be rupees 1812, right. Now, total your what you call annual your residential energy is consume 800 kilowatt hour. So, if you take the average, so average cost per this thing will be rupees 1812 divided by 800 kilowatt hour. So, that comes approximately on an average rupees 2.265 per kilowatt hour. Right. This is a simple example, because we have taken that energy we are talking of. So, just P into your time, power into time, right. Before going to the next example, sometimes we call in English rhymes that energy is power multiplied by hour. Rather, I can put in better way that electrical energy is power multiplied by hour, right. So, that is kilowatt hour, because kilowatt is the power and hour is the time. So, next is this is a simple example I took for you. So, hope it is understandable, very simple thing, right. Next example 13. So, you have to determine the power absorbed or supplied by each component of the circuit as shown in figure 19. This is figure 19. This is one electrical element, is 5 volt is given plus minus, it actually either supplied or absorbed, we will see later that power P1, this is a voltage source, right. This is another dependent voltage source, and this is another source is there, only terminal plus minus 3 volt is given. So, we have to find out that power absorbed or supplied by each of the source. Now, look, this 8 ampere current, this is the 8 ampere current, it is first you let us start from this your this element whose voltage across it is 5 volt, right. So, and power we have to find out P1 is the power supplied or absorbed. So, this 8 ampere current, actually this current actually come leaving the plus terminal, right. Leaving the plus terminal means it is your what you call sign will be negative and power supplied actually, right, because this 8 ampere, if you look at the direction of the current, this 8 ampere current actually leaving the plus terminal. So, P1 will be your minus 5 into 8 minus 40 watt, that is supplied. Look at that 8 ampere current is out of the plus terminal, everything I have written for you, but I am explaining it. So, P1 will be 5 into minus 8, so minus 40 watt, so power supplied, right. So, P1 is the power supplied. Now, this 8 ampere current is entering into the positive terminal. Whenever it enters into the positive terminal means this source actually is absorbing power. So, in this case it is 2 volt and 8 ampere. So, P2 will be 8 into 2 16 watt, that is power absorbed. So, if you look into that, 8 ampere current is entering the plus terminal of P2. So, P2 will be 2 into 8, so 16 watt power absorbed, right. Now, next is the 3 ampere. Now, here it is now this 8 ampere current, 3 ampere is going here, 5 ampere is going here. Now, this is a dependent voltage source. Now, you see that this is 0.6 I and this is 5 ampere. So, if you multiply 0.6 into I, it will be 3 ampere. Just hold on. So, if it is your 0.6 I, so it will be 0.6 I is equal to, here it is 5 ampere. So, it will be 0.6 into 5. So, it will be 3 volt. That means volt for I is equal to 5 ampere, voltage of the dependent voltage source, it is actually is equal to 3 volt, right, 3 volt. Now, this 3 ampere current is entering into the your what you call positive terminal. So, power is being absorbed. So, it will be 3 ampere into 3 volt. So, P3 will be 3 into 3, 9 watt, that is absorbed, right. So, just hold on. So, in this case, so in this case your so if you see that P3 is equal to your 0.6 into 5, I told you that is 3 volt into 3 ampere. So, 9 watt power absorbed, right. So, next is this 5 ampere, this 5 ampere current entering into the positive terminal, right. That means, as entering into the positive terminal means it is power absorbed. So, it will be P4 will be 5 ampere into 3 volt. So, 15 watt. So, P4 will be 3 into 5, that is 15 watt power absorbed. So, power supplied is, it is taken minus 40 watt and your power absorbed here is 16 watt, here it is 9 watt. So, 16 plus 9 25, here it is plus 15. So, 40 watt. So, power supplied is minus sign indicates power supplied. So, supplied is 40 watt and absorbed is also 40 watt. So, perfectly matching. So, now absorb your power supplied and power absorbed. I hope this thing is clear to you now, right. Next is another example. Now, this is actually state which interconnection in figure 20 are valid and which are invalid. You have to tell there are 4 connections, that which connections are valid and which connections are invalid. Now, take this connection 1. Here the terminal 1 and terminal 2. So, across terminal 1 2 that a voltage source is connect, V is equal to 5 volt. Now, when and across 1 2 also a dependent voltage source is connected, Vs is equal to 4V. So, if you put 5 your V is equal to 5. So, Vs will be 4 into 5. So, 20 volt. So, but across it is your across the say your 1 2 same terminal you cannot connect to different voltage source. So, this is an invalid connection. So, this is invalid connection. Now, if you come to this one, here V is equal to 5 volt and Is is equal to 2 into V. So, V is 5 volt. So, Is basically 2 into 5, that means your 10 ampere. So, it is a valid circuit connection, right. One voltage source is there, one dependent current source. So, this is a valid connection, but this is invalid connection. Now, here if you come, here a current source is given, Is is equal to 2 ampere, but a dependent voltage source Vs is equal to 4 Is, but this Is is equal to 2 ampere. So, Vs is equal to 4 into 2, 8 volt. So, it is a current source, it is a dependent voltage source, they are in series actually, later we will see that. So, it is a valid connection, this is a valid connection and they are connected across terminal 1 2. So, it is a valid connection. Now, this one a current source is there, Is is equal to 3 ampere and a dependent current source is there where Ix is equal to 3 into Is. Now, when Is is equal to, all I am not writing, I am telling from my mouth, I think it is understandable to you, simple thing. So, Is is equal to 3 ampere. So, I is equal to 3 into 3, so 9 ampere, but this is 3 ampere and this is coming 9 ampere. So, it is not possible, right. So, this is an invalid circuit. So, this circuit, this one invalid and this one is invalid and these two are valid circuit. B and C are valid circuit connection and A and D, these are invalid connections, right. So, I hope it is understandable to you, because why I have taken this one, such that starting from the beginning we have to know we have to know all these things, because later stage we have to solve different type of problem. So, starting from the beginning we have to clear our ideas. So, so all these things I have written here, but later you can go through this when you will go through the video, you can go through once, but I have explained that exactly what it is, right. So, everything I have written here, but I have explained. So, not further your what you call going through this. Now, this one, now determine the power supplied or absorbed by each component in figure 20. It is 1.21, but I am telling 1.2 that is chapter 1 21 figure. So, I am telling figure 21. So, here 1, 2, 3, 4, 4 elements are there, and current is I, this 10 ampere, this I actually is equal to 10 ampere. So, this is I, this is your I, right, and this I is equal to actually 10 ampere. So, this I is equal to 10 ampere, this I is equal to 10 ampere. Now, this your what you call this I 10 ampere, this is leaving the terminal, this one, this 16 volt source, just hold on, this this is a 16 volt source. So, 10 ampere current is leaving the terminal, your what you call positive terminal. So, that means power supplied as is leaving this power, this thing. So, this is 16 volt source here, and this is your sorry, this is 16 volt, and this is actually current source plus minus, this voltage across this is 16 volt. So, this is a current source. So, 10 ampere current, it is entering into this your what you call this negative terminal of 6 volt. So, this is a current source, and voltage across this is 16 volt, right. This is a current source, I have overlooked actually, it is a current source, and this is a voltage, this is a voltage source, this is a voltage source, and this is a dependent current source. So, in this case and across this voltage is 16 volt, then first you have to find out P4 is there, P2, this is P1, this is actually P1, just hold on, let me correct this, this is actually your P1, right, this is P1. So, just hold on. So, this is P1, I have corrected that. So, now this current source, now this current source, so is actually supplying power, because it is leaving this terminal. So, P1 will be equal to 6, it will be minus 16 into 10. So, minus 160 watt. So, P1 is equal to 16 into minus 10, this is power supply, right. Now, next is if you look into this 10 ampere current entering the negative terminal, other way actually it is leaving the current, leaving the plus terminal, because this is entering minus terminal, okay, but because either entering minus terminal or leaving the plus terminal, that means 6 volt also it is supplying power, because this is the direction of the current, if current is flowing this direction. So, basically this current entering into the minus terminal, leaving the plus terminal. So, P2 actually this source actually, or what you call it is supplying power. So, it will be minus sign, right. So, in that case P2 will be 6 into minus 10, minus 60 watt power supplied. So, this is your 6 into minus 10, this is the 10 ampere current source is there, current source supplying 10 ampere current here, this current is 10 ampere. So, it is minus 60 watt. Now, next is this 6 ampere another 6 ampere current entering into this 22 volt source. So, it is entering into the positive terminal. So, as it is entering into the positive terminal means this voltage source actually, this source actually is absorbing this absorbing power. So, it will be P3 will be 22 into say 6. So, it will be 132 watt. So, P3 will be your 22 into 6 132 watt. So, power absorbed, right. Next is that this is your another your dependent current source. So, here what you call here 0.4 I. So, I is equal to 10 ampere, just hold on, I am writing for you. So, 0.4 I. So, this is your 0.4 and I is equal to 10. So, this is actually 4 volt, right, this is 4 volt, and this one this is actually plus terminal, this is minus terminal, right. So, this is this actually this is an wire, this is a wire only, this is a wire only. So, plus minus means here it is plus, here it is minus. That means here it is plus, here it is minus, and this is plus, actually this is minus. That means the direction of the current is this way. So, that means current is actually entering into the positive terminal. That means this source, this dependent current source actually absorbing power. I hope I hope your understanding will be clear. Look, this is plus minus, that means this is plus, this is minus, and this your current direction is this way. So, this is plus minus means this is also plus, this is also minus, and this is the direction of the current. That means current is entering into the positive terminal, because this is positive terminal. That means this source and this, here it is your what you call, here it is this is your current source, sorry, this is 4 into 10, it is your 4 ampere, sorry, it is current source. So, it is 4 ampere, right, it is 4 ampere, sorry, right. So, this is your 4 ampere. Now, what is the voltage? So, no other electrical element is there. So, across this current source, the voltage is also 22 volt, because here it is across this, it is 22 volt. So, same voltage will be impressed across this your dependent current source. So, this is actually your 4 ampere. So, that means 22 into 4, the power absorbed by this source will be 88 watt. So, if you just hold on. So, I am deleting this one, right, just hold on, right. So, if you come to this, that is your, this is your actually, this is P4. So, this is actually your P4 is equal to, look, 22 into that 0.4 into 10, 4 ampere, so 88 watts. So, power absorbed. Now, if you add 132 and your 88, this is power absorbed, whatever it will come, 220 or so, right. And if you see the power supplied, it is 160 minus and minus 60, so minus 220. So, it is exactly matching. So, this way you have to understand. I hope you have understood this, because no other element. So, whatever 22 volt is there, that will be impressed across this dependent current source, and I is equal to your 10 ampere. So, it is 4 into I, so 4 ampere, and voltage across this your dependent current source is 22 volt. So, 22 into 4, because whatever volt I told you just now, that showing polarity sign. So, this way you can, I mean, we have to your what you call, we have to clear our concept about all these things, then only we can solve things easily. So, there should not be any path for confusion or anything. Even when I am writing also, 1 or 2 places I am overlooking, your what you call looking on this, but it is a current source, it will be 4 ampere. So, by mistake I wrote 4 volt. So, it is your what you call, I overlook this. So, this is your 4 ampere. So, I hope it is understandable to you, right. So, next one you look. So, right. So, next one is these are very small thing, but very tricky when you are starting your learning this course. So, if you clear our concept about this, you will find things are very interesting in the latter stage, right. So, for example, figure 22 shows a circuit diagram, determine the power supplied or absorbed by the voltage source. For first one, it is given V is equal to 1 volt and I is equal to 2 ampere. You have to find out the power supplied or absorbed by the voltage source, that means this voltage source, right. So, first one is given V1 is equal to 1 volt and I is equal to 2 ampere. So, when I is equal to 2 ampere, right, when I is equal to 2 ampere, so I is equal to 2 ampere, right, 2 ampere, and this is the direction of the current, this is the direction of the current. That means the current actually flowing like this, that means this current actually entering into this your plus terminal. That means the voltage source actually, this is actually it absorbs power, because it is entering into the positive terminal. That means, but voltage is 1 volt. So, V is equal to, it is given for this case 1 volt and I is equal to is given your 2 ampere. So, it will be 2 into 1, that is 2 watt power absorbed by the voltage source. So, here I have, so this is actually just hold on. so I am rubbing this, so it will be power absorbed by the voltage source. So just hold on, right. So this one, this is the 2 watt, the power absorbed. Now next one, it is given, look, that V is equal to 6 volt, but I is equal to minus 4 ampere. So in this circuit, I am drawing it again for your understanding. It is that case B, that is that for this case, this is case B. So V is equal to 6 volt, but your current is I is equal to minus 4 ampere. That means the direction of the current will be reverse. So that means if I for your understanding, if I draw it like this, that because I is equal to minus 4 showing this direction. So I am making this arrow this direction, and this is your voltage source. Voltage is 6 volt. So V is equal to 6 volt, second case, it is in the second case, V is equal to 6 volt, and I is minus 4 ampere this direction. That means this direction I is equal to, I can write positive 4 ampere, and this current actually is flowing like this, it is flowing like this, That means the current actually leaving the voltage terminal, because it is direction is like this. So basically the current actually leaving the your plus terminal. That means your power will be, your I is given 4 ampere and voltage is 6 volt. So P it will be 24 watt, but it is leaving the plus terminal, that means power supplied. So minus 24. So power supplied by the voltage source, right. So so let me clean this one. Again I will be back to you, right. So just hold on. So if you come to this, your this is your P is equal to VI, power supplied, the second case, right. Now third case, it is given that V is equal to minus 12 volt and I is equal to minus 16 ampere. So in this case, just for your understanding, again I will draw for the case C. So this is your just hold on. This is your case C. It is V is equal to minus 12 and I is equal to minus 16 ampere. So what you can do, the easiest way, rather than complicating the thing. So this is my current source, right. As I is equal to minus 16 ampere. So direction of I is given. So this is the positive direction. When I is positive, this is the direction is given, which is minus 16 means you just make the arrow downwards, right. And this one, your voltage also, source also, it is given minus 12 volt. So this one, if you make minus and this is like plus, so that means voltage is equal to, you can write 12 volt, and this is your I is equal to, you write your 16 ampere. What I did for your understanding, as V is equal to minus 12 volt, I have reversed the direction of the current, because it is, sorry, I is equal to minus 16 ampere. So I have reversed the direction of the current, and V is equal to minus 12 volt. So I have reversed the polarity. So that means the current is flowing in this direction, That means the current actually entering into the positive terminal of the voltage source. That means it is absorbing power. So P will be equal to your 16 into 12 watt. This power, it is being absorbed by this voltage source, because it is entering into the positive terminal, right. So it will be actually 192 watt, right. So I hope you have got it this, right. So make things simpler way, better we should not make the thing complicated way. So make the thing simplest way, such that you will understand each and everything. Okay, then now let me clean this one. So that is why all calculation I have made, this power absorbed 192 watt, everything is here, but everything I am trying to make it for you. Then this figure, this is example 17. Now figure 27 shows a circuit diagram. Determine P1 and P2 where I is equal to 4 ampere and I is equal to minus 3 ampere, right. So when I is equal, this is a your dependent voltage source, this is a dependent voltage source, and first case is I is equal to 4 ampere. So the first case, that I equal to 4 ampere, right, and it is a dependent voltage source. So this, it is 2I. So, here voltage will be 2 into your 4, because first case, this case it is I is equal to 4 ampere. So, in this case what will happen, that this is your 2 into 4, this is volt, that means it is 8 volt, right, and this I is equal to 4 ampere, this current actually entering into the positive terminal of this dependent voltage source. That means this this I is equal to 4 ampere first leaving this voltage, leaving this plus terminal. That means when leaving the plus terminal, that means voltage P1, that is the 8 volt source, it is actually supplying power. So, when it is leaving the plus terminal, it will be minus, and voltage is V is equal to 8 into I is equal to your 4 ampere. This is the 4 ampere. So, minus 4. So, minus 4. So, this will be minus 32 watt, right. This is the power supplied, right. This is power supplied. Now, the another thing is, this current is entering into the dependent voltage source, the plus terminal. That means this source actually absorbing power. So, here it is 8 volt and 4 ampere current is entering, because I is equal to 4. So, it will be P2 will be is equal to 8 into 4. So, 32 watt. So, this is actually power absorbed, right. So, hope this thing is totally clear to you. So, let me clean this. Right. Second case I is equal to minus 3 ampere. Just tell me one thing, this one, second case, this one please do not read, I am striking it off, right. Second case, this one, the second case, this do not read, here it is, that calculation here it is wrong, this do not read, I will explain what exactly. This one you should not read, the second case. Second case I am explaining on this your what you call on that on the problem itself, just hold on. So, this you should not read for the second case, right. So, now I am going back to that problem. Let me clean this. So, just hold on. So, second case, your I is equal to your minus 3 ampere. Now, what will happen if I is equal to minus 3 ampere? So, what I will do, I will redraw this circuit. So, in this case, just hold on. So, in this case, that I is equal to minus 3 ampere. So, what I will do, this is dependent voltage source, this is plus minus, this is your this is your voltage source, this is plus, this is minus 8 volt source, this is the current source, right, and as it is I is equal to minus 3 ampere. So, a direction is upward. So, as it is minus 3, so we are taking this direction, say I is equal to 3 ampere, and this is my 8 volt, and this is your 2I, right. This is dependent voltage source. Now, in this case here it will be 2 into 3, that is equal to 6 volt, right. Now, this is 8 volt. So, if you look into that this 3 ampere current actually, if current is moving like this, so 3 ampere current is, this is actually P1 and this is your P2. So, in this case 3 ampere current entering into the your what you call positive terminal of this voltage source. So, that means power absorbed by this voltage source, this is P1. So, P1 will be is equal to 8 volt into that 3 is equal to 24 watt, right, 24 watt. So, this is power absorbed. Now, and in this case for dependent voltage source, this actually leaving the plus terminal. So, P2 will be negative, power supplied, and P2 will be is equal to your, this is 6, this is minus minus sign, power supplied. So, it is 6 volt, 2 into 3 dependent voltage, so 6 volt, it is 6 into this 3. So, it is minus 18 watt, this is actually what you call the power supplied by the, this is absorbed and this is minus sign means power supplied. So, if you add this 24 minus 18 algebraic sum, so 6 difference is there. My question is to you, power balance has to be matched, because absorbed power plus your supplied power is equal to 0, but here it is 24 minus 18, 6 watt. So, difference is there, where that power has gone. So, just hint is that you calculate, I am not telling, this source actually is supplying another 6 watt power, right, this current source, then only it will match. So, you find out from where you will get this 6 watt. This is an example, this is a your what you call problem for you, you should solve this one, right. So, so I am so this is the problem actually. So, whatever I have rubbed it there, do not go through, this is the problem. So, 6 difference is there, I am telling you this current source actually supplying 6 watt, but you calculate from how 6 that 6 watt you calculate from your side, that how can you calculate that. I will not tell here, but it is an exercise for you, right. So, I am let me clean this. So, do not see that one. So, now this one you have to tell which is your what you call valid connection and which is invalid connection, that is the thing. Look, this is 1 2 terminal. So, across this 10 volt, this is also 10 volt. So, these two sources are connected actually in parallel, later we will see. So, this is a valid connection, right, because 10 volt valid connection. Now, here one 5 ampere current source is there at 10 voltage, another 10 volt, both are connected across terminal 1 2, absolutely no problem. This is also a valid connection, right. These two are valid connection, because any across any terminal you can only connect the equal voltage source. If there is a difference, then that is invalid connection, that is not possible. And any current source and this voltage source, this is also a valid connection. Now, this one across this terminal 1 2 is a 5 volt and it is a 10 volt, it cannot be, two cannot be different, right, it has to be same, because they are connected across the same terminal. So, this is invalid connection. Similarly, this 1 2 ampere current source, another 5 ampere, in this it is not valid, because it is a simple circuit. So, this is invalid connection, this is invalid connection, because here it is 5 ampere, here it is 2 ampere, it is not possible. So, because 5 ampere 2 ampere cannot flow like this, either it has to be 2 or it has to be your what you call this 5, but both the way we have connected, it is invalid connection. Similarly, here also it is invalid connection. So, A, B are valid connection, C, D are invalid connection. So, everything is written there, everything is written there. So, just you will go through. Now, these are all exercise. So, exercise 1, answers are given, not reading again. When you will read this video, you can pause and see this problem. So, your this problem 2. So, answers are given, hope these all answers are correct, you will solve it. Now, problem 3. So, this is also your power absorbed, power supplied problem, right. So, all answers are given. And problem 4, this is also given, the total charge entering the element, this is also answers given. So, this is problem 5. So, you will do this, all valid or invalid connections. So, you will solve this one, right. So, this is one, then and answers for everything, this is not valid for invalid connection, it is actually circuit inside the box absorbing or supplying power, right. Everything is given, you read this problem very carefully and do this A, B, C, all the C, D 4 connections are there, accordingly you will make it. Answers are also given, right. And problem 6, this is your voltage, your voltage 0 for time varying voltage actually given. So, you have to find out the energy delivered, answer is given. So, this is, there are 5 connections here, you have to see that whether how many of them are valid or invalid, right. There are 5 connections and all answers are given. And this is also a time varying we will see for AC circuit, but this is simply given, you have to find out the energy, the joule absorbed, right. And this is another simple problem, right. You have to find out that you have to just answer is given, right, that stove element this much when connected to this long, how long does it take to consume 30,000 joules. So, answer is given. And this is the last one, this is the current time varying, your what you call current is given, right. You have to find out total passed charge through the element, right, and these answers are given. So, everything is given. So, thank you very much, we will be back again.